on Earth.
At least one scanning electron microscope image revealed a structure that looked suspiciously organic, almost like a worm. Could it be a trace of primitive Martian biology?
I think that worm is biologic. Whether it's a complete fossil of bacterium is problematical. It could be a part of a bacterium. It could be a section of one, but it's biologic in my view.
I'd like to welcome everybody here today. It's an unbelievable day. It's very, very exciting for me.
Finally, in 1996, after more than 2 years of study in which they had built 4 independent lines of evidence, the team was ready. They announced their hypothesis. ALH 84001 contained possible evidence of past life on Mars.
We conclude that this is evidence for early life on Mars.
NASA held a major press conference, but not everyone was convinced. Labs across the globe requested samples of the rock to conduct their own analyses. In the end, after months of, at times, acrimonious debate, the consensus was that there was no consensus. Papers were published in support of the claim, but many more were published debunking the idea.
If I could have the first slide, please. The features that you see may be any number of things. For example, they could...
Many researchers are convinced that the formations in the rock that appear to be signs of Martian life were actually caused by mineral activity.
The majority of people would say that there is no relic biogenic activity in this meteorite from Mars. Dave's initial hypothesis was incorrect. I would say at this point that that's too simple a hypothesis to take. I don't think the work has been completed to a satisfactory endpoint to say either way.
Work on the meteorite is continuing. But even if researchers never confirm that the rock contains signs of Martian life, the ALH 84001 episode has already completely reinvigorated interest in the quest for life on the red planet. Ironically, the new push to find life on Mars has often led scientists yet again to the continent of Antarctica. Conditions in this part of the world are analogous in many ways to conditions on Mars. Seeking out life forms that manage to thrive in extreme circumstances here might shed light on how and where primitive life could have once taken hold on the red planet. One environment astrobiologist Dale Anderson focuses on is at the bottom of lakes, covered year-round with thick layers of ice.
Most people said that because of the thick ice covers, you would find nothing but rocks. There would be very little to nothing on the bottom.
The ice layer sealing off many of these lakes is up to 15 feet thick, but rather than trying to blast or drill through it and disturbing the ecosystem below, Anderson and team have found a much less damaging approach. They let a massive coil of copper tubing make an opening.
Then you just pass a hot liquid through it, throw it out on the ice, and let it melt its way down. It takes about 24 hours. It melts through the ice, then we put this very nice clean hole to dive through.
Divers enter the water wearing full-body dry suits. And what they find at the bottom of nearly every Antarctica lake bed is a testament to the stubborn tenacity of life. Mats of microbial organisms are thriving in frigid environments that receive virtually no sunlight.
Most people thought that if you had less than about 1% of the surface light, you wouldn't have any photosynthesis taking place down the bottom. They wouldn't be able to use enough light to live. It's turned out that they can photosynthesize with light levels down to 1/10 of 1%.
For Anderson and his team, the pristine mats are truly a window to the past.
There are no higher organisms, no fish, no insects, no animals creeping through it. So these microbial communities have the opportunity to grow by themselves without interference from other animals or plants. And that gives them the opportunity to grow in very special ways.
Is it possible that a similar form of microbial life could still reside somewhere beneath the frozen surface of Mars? Especially at the hydrogen-rich poles? Anderson and scientists like him believe it is worth investigating.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, engine ignition, and liftoff of the Delta II rocket with the Mars Exploration Rover.
In the summer of 2003, NASA's Jet Propulsion Laboratory delivered 2 exploration spacecraft to the surface of Mars. Missions to the Red Planet are only feasible once every 2 years during a specific short window of time. The launch must be timed so that the spacecraft and Mars arrive at a specific point in the planet's orbit at the same time. The journey across the 34 million mile distance can take up to 7 months. And the trajectory must be perfect.
The accuracy required to go from Earth to Mars and to hit the spot you want to be at on Mars is equivalent to shooting a basketball from Los Angeles to New York and have it go through without hitting the rim. Nothing but net.
All systems are go for entry, descent, and landing. We are currently 6 minutes from landing at the Gusev crater in the southern hemisphere of Mars. Current velocity 1,356 miles per hour. Expected parachute deploy in 5 seconds.